Welcome to the walkthrough for assignment 1A, frequently made mistakes. First, please make sure to document your code thoroughly and make sure you run the unit tests and make sure the tests pass. If the tests don't pass, please come to office hours and ask questions. Let's take a look at some of the problems with the code. Here's a problem with run simulation. This implementation here doesn't fulfill the specification. You're supposed to call create and start waiter for being threads and store the result into a local thread object. And then you're supposed to use that local thread object to wait for the results by joining. Therefore, this implementation also doesn't fulfill the specification. You should not call shutdown now. It's simply a no-op. Let's take a look now at a common mistake that people made for new being, which is a factory method. All you have to do here is just say return new simple being runnable this rather than creating a local variable and then returning that. That code isn't wrong, of course. It's just unfortunately too verbose. Let's now go ahead and take a look at the various problems with begin being threads. There were lots of problems here. In this particular case, this code is not wrong either. It's just not as streamlined as it could be. All you need to do is say get beings.forEach as opposed to get beings.stream.forEach. Come down a little further. Let's take a look at another common problem. In this code, you need to use the variable I, or whatever you call the loop variable, as the parameter to thread instead of what's being done below. You don't want to call simple being runnable this. That's what's done earlier in the new being factor method. So you don't need to do that. Lots of interesting problems in this implementation of begin being threads. First, again, don't use the simple being runnable. Instead, just use the being argument that's coming through the for each loop. Very, very important thing. Never, ever, ever please call run directly. You never want to do that. Instead, you want to start the thread and let that run method be called back by the thread in the thread framework in Java. This code down here is completely unnecessary and erroneous. If start is called properly on each thread, you don't need to be doing this. And again, never, never, ever, ever call thread run directly. That's a very problematic thing in Java because it means you're messing up the abstractions of threads and you're not getting the benefits of any threads either. Let's continue on down below. Please don't use index-based for loops, but instead use for each loops. Or in some other cases, you can use other things like the for each method, as we'll see down below. So don't use the index-based loop. It's tedious and error-prone to write. Down here, please use the for each method defined on being threads instead of an index-based for loop. And also when you use the for each method, please make sure to use a method reference in order to ensure the thread gets started. Come down a little further. You can see that we have begin being threads. The person here is doing some cool stuff with a Java stream, which is good. In this case, you can actually integrate the Java stream peek operation into the stream above. You can basically do it here. And if you do that, then you'll be able to get the right behavior. So you don't need to have an extra for each call here. You can just integrate that in with the stream above. And as I mentioned earlier, please don't use for each loops or index-based for loops for starting the threads, but instead use the for each method and the thread start method reference. Now let's go ahead and turn our attention to problems with create and start waiter for being threads. There's a number of common problems here. First thing is please get in the habit of using a lambda expression instead of an anonymous inner class. Just more verbose. It's unnecessary to do it with an anonymous inner class. A lambda expression works perfectly fine. Similar problem here. Please use a lambda expression instead of a nested class. There's no need to have a nested class here. It just clutters things up. It works, but it's just not the modern way of doing things in Java. Take a look at another issue. This is something I warned you about in class, but it's something that you need to keep in mind. Please never, ever, ever use the zero parameter thread constructor. Instead, what you need to do is you need to create a lambda expression that performs a barrier synchronizer loop that involves multiple calls to join for the various threads that are in the being threads list. And in particular, this code is incorrect. You don't want to be joining with that thread. That makes no sense, especially because it doesn't do anything, because it has no parameter passed to it. But instead, you want to join all the threads in the being threads list. And there's also no need to call shutdown now, since it's essentially a no-op. If you look at the code, there's nothing there. Let's now turn our attention to the acquire, palantiri, and gaze method, which is from the other file. Make sure that you don't do checks for null and don't do the error calls in the try statement. Instead, you want to hoist those things out of the try statement. And that way you can ensure that the release palantiri method is never called if acquire palantiri returns null. Going down here a little bit further, similar kind of problem. We want to hoist the call to acquire Palantir outside the try block and also move the check to see whether open P is not equal to null. That needs to be moved out of the try block too. And once you do that, then there's no longer any need of doing this second check for null below. It's not necessary if you refactor the code, as per my comments above. Take a look here. Here's acquire Palantir and gaze. In this case, it's not using the try finally block at all. So make sure you use a try finally block. Otherwise, if an exception occurs, then the code will leak palantiri, which we don't want. We want to make sure that the palantir is properly released, even if an exception is thrown. And that's something that's checked for by the unit tests. Let's come down here and take a look at another erroneous implementation of acquire Palantir and gaze. Don't be calling acquire Palantir in a try statement or in an if statement at all. It doesn't belong in either of those things. You just need to get its value back and then check its value to see whether it's null or not. And this is also an improper use of a try finally statement. You actually have to make the try finally statement wrapped around the gaze and release Palantir method, not around the finally part. I'm not even sure what this is trying to do, but code is very buggy. And let's see, one final acquire Palantir and gaze problem. In this case, there's no need to call mmanager is shut down. That's unnecessary. That's handled elsewhere in the framework. And also, the call to release Palantir needs to go into the finally portion of the try finally block above. So that's very important to make sure that the Palantir is always released, even if an exception is thrown. So that's the end of our walkthrough of frequently made mistakes for assignment 1A. I will post this video on YouTube, and hopefully you can learn from it and ask any questions you'd like in office hours or in class.